If you drive a Honda, you probably bought it for one reason above everything else: reliability. You wanted something that starts every morning, survives impossible mileage, and keeps running long after most cars should have died. And Honda built its reputation on exactly that. Civics that reach 300,000 miles, Accords that outlive entire families, CR-Vs that refuse to quit no matter how badly they're treated. But here's the part most Honda owners never hear. Some of the most expensive Honda failures ever recorded were not caused by defective engines, bad engineering, or factory mistakes. They were caused by owners slowly destroying their own vehicles without realizing it. And the worst part is most of these habits feel completely normal. They feel harmless. Some are even recommended by people who think they know cars. Today we are counting down 15 expensive mistakes Honda owners make every single day that quietly destroy transmissions, ruin engines, damage cooling systems, and trigger repair bills that can exceed the value of the vehicle itself. And the number one mistake on this list has killed more Honda engines than almost anything else Honda has ever faced in its modern history. Number 15. Using cheap aftermarket sensors instead of genuine Honda electronics. This is one of the fastest ways to turn a perfectly reliable Honda into an endless check engine light nightmare, and most owners never realize the damage starts long before the warning lights appear. Modern Hondas are heavily dependent on sensor accuracy. The mass airflow sensor, crankshaft position sensor, oxygen sensors, VTEC solenoids, throttle position sensors, and camshaft sensors all communicate with the ECU hundreds of times per second. On engines like the K24 found in the Accord and CR-V, or the turbocharged L15B7 in the Civic and CR-V, those sensors are not generic components. They're calibrated to extremely specific voltage ranges and timing windows. The problem starts when a cheap aftermarket replacement sensor gets installed because it costs half as much as OEM. On the surface, the car still runs, it still starts. The check engine light may even stay off temporarily. But internally, the ECU is now receiving inaccurate data. Fuel trims drift slightly lean or rich. Ignition timing becomes inconsistent. Variable valve timing activation no longer happens exactly when it should. The damage is gradual. That is what makes this so dangerous. A cheap oxygen sensor can cause excessive fuel enrichment that slowly overheats the catalytic converter. A bad NOx sensor can prevent ignition timing from adjusting correctly under load. A low-quality crankshaft sensor can create intermittent misfires that destroy engine mounts and stress the transmission. And Honda ECUs are notoriously sensitive to electrical irregularities, especially on the 1.5 turbo engines, where precise fueling is critical. A genuine Honda sensor may cost $120 to $300. Cheap aftermarket versions flood online marketplaces for $25 to $60. But replacing a catalytic converter on a Civic Touring can exceed $2,000. Replacing an ECU damaged by electrical inconsistencies can push past $1,500 before programming. This is one of those mistakes where saving money creates the repair bill in the first place. Number 14. Ignoring the Serpentine belt and tensioner. Most Honda owners never think about the Serpentine belt because, unlike a timing belt, it sits right in front of the engine where it looks simple and harmless. But on many Honda engines, especially the J35 V6 found in the Pilot, Odyssey, Ridgeline, and Accord, the Serpentine belt drives nearly every critical accessory the engine depends on. The alternator, the water pump, the power steering pump on older models, the AC compressor. Everything depends on that single belt maintaining proper tension at all times. The problem starts when the belt ages and develops micro cracks between the ribs. Rubber hardens with heat cycles, the tensioner spring weakens, bearings inside the pulleys begin wearing unevenly. Most owners ignore the chirping noise because the vehicle still drives normally, but the damage is already happening. A slipping belt reduces alternator output, which creates low voltage conditions throughout the electrical system. Honda transmissions, especially older 5-speed automatics in the Accord and Odyssey, are extremely sensitive to voltage irregularities. Weak charging systems can cause erratic shift behavior that owners mistakenly blame on the transmission itself. Then comes overheating. On many J-series engines, the water pump relies on consistent belt speed to circulate coolant properly. Once belt slippage becomes severe enough, coolant flow drops under load and temperatures spike unpredictably. The owner sees the temperature gauge move slightly higher than normal for a few days or weeks, then one day the vehicle overheats hard in traffic. A warped cylinder head repair on a Pilot or Odyssey can exceed $4,000. A snapped serpentine belt that gets pulled into the timing cover area can create catastrophic engine timing issues on interference engines. A belt and tensioner replacement costs roughly $250 to $500, depending on the model. Ignoring it long enough creates repair bills 10 times larger. And several mistakes higher on this list make overheating even worse.
Number 13. Neglecting brake fluid flushes. This sounds minor. It is not. Brake fluid is hygroscopic. That means it actively absorbs moisture from the atmosphere every single day through microscopic pores in the brake lines and seals. Even if the reservoir looks clean, water contamination is slowly increasing inside the system. Honda braking systems are particularly vulnerable because many models use highly integrated ABS and stability control units with extremely narrow hydraulic passages. The Accord, Passport, CR-V, and Civic Touring all rely on sophisticated electronically controlled brake modulation systems that absolutely hate contaminated fluid. The problem starts quietly. As moisture accumulates, the boiling point of the brake fluid drops dramatically. Under heavy braking, especially downhill driving or repeated highway stops, microscopic vapor bubbles form inside the hydraulic system. Pedal feel softens, stopping distances increase slightly. Most drivers adapt without realizing it, but internally, corrosion is beginning. The ABS modulator develops rust inside the valve body. Caliper pistons begin pitting, rubber seals slowly degrade from contaminated fluid chemistry. And once corrosion starts inside the ABS unit, replacement becomes brutally expensive. A brake fluid flush on a Honda costs roughly $100 to $180. An ABS module replacement on a newer Honda Accord or Hybrid or CR-V Hybrid can exceed $2,500 with programming and labor. Full caliper replacement on all four corners can push another $1,200. Honda actually recommends brake fluid replacement roughly every 3 years, regardless of mileage. Most owners never do it once during the life of the car. And by the time the brake pedal feels noticeably wrong, the internal corrosion has already spread through the system. Number 12. Using the wrong coolant or mixing universal coolant into Honda systems. This is one of the mistakes that destroys Hondas slowly enough that owners almost never connect the damage back to the coolant itself. Honda cooling systems are engineered around Honda Type 2 blue coolant. That coolant uses a very specific silicate-free formula designed for the aluminum alloys, gasket materials, water pump seals, and radiator construction Honda uses across engines like the K24, J35, and L15 Turbo. Universal coolant looks harmless because coolant colors mean almost nothing today. Green, orange, yellow, blue, pink. Most people assume they are interchangeable. They are not. The problem starts when incompatible additive packages react chemically inside the cooling system. Corrosion inhibitors begin neutralizing each other. Deposits form inside radiator passages and heater cores. Water pump seals experience abnormal wear because lubricant chemistry changes. On turbocharged Hondas like the Civic 1.5T and Accord 2.0T, cooling system stability is absolutely critical because turbocharger temperatures are extreme compared to naturally aspirated engines. Even minor coolant degradation accelerates thermal stress, and Honda engines are extremely intolerant of overheating, especially the J35 V6. Repeated minor overheating events warp aluminum cylinder heads gradually over time. Head gasket sealing weakens. Coolant passages begin developing corrosion internally, where owners never see it until coolant consumption starts. A genuine gallon of Honda coolant costs around $30. A water pump replacement on an Accord V6 can exceed $1,200. A heater core replacement often requires dashboard removal and can approach $2,000. A head gasket repair on a Pilot or Odyssey routinely exceeds $4,500. The coolant is not where you save money on a Honda. Number 11. Shifting between reverse and drive before the vehicle fully stops. Honda transmission technicians see this constantly. You back out of a parking spot. The car is still rolling backwards slightly. You throw it into drive. Then later, you pull into another spot and shift into reverse while still creeping forward. It feels completely harmless because the transmission does not explode immediately. The vehicle keeps moving. Nothing dramatic happens. But inside the transmission, enormous mechanical stress is occurring every single time. Honda automatic transmissions, especially older 5-speed units used in the Accord, Odyssey, Pilot, and Acura TL, rely on clutch packs and planetary gear sets that are extremely sensitive to shock loading. When the vehicle is still rolling one direction and the transmission suddenly commands the opposite direction, the clutch assemblies absorb the entire momentum change instantly. That friction material wears away microscopically every single time it happens. Heat builds, clutch surfaces glaze, metal particles contaminate the transmission fluid. Pressure control solenoids begin sticking from debris contamination. Eventually, the shifts become slightly delayed or harsh. Most owners ignore it because the transmission still technically works. Then, one day, third gear slips. Honda's older automatic transmissions already developed a reputation for premature failure under heat stress, especially in early 2000s V6 Accords and Odysseys. Aggressive directional shifting accelerates the exact wear patterns those transmissions are known for. A transmission fluid service costs around $180. A rebuilt Honda transmission can cost $4,000 to $7,000, depending on the model. And there is another transmission-related mistake later on this list that has quietly destroyed more Hondas than almost anything else. Real quick, before we get into the top 10, looking at the numbers on this channel right now, most people watching still are not subscribed, which means the algorithm has absolutely no reason to show you the next video, even though you are clearly the kind of person who actually cares about keeping your Honda alive long-term. Subscribe so the next one ends up in your feed instead of someone who is going to ignore every maintenance item on their car. Number 10. Ignoring valve adjustments on older Honda engines. This is one of the most uniquely Honda-specific mistakes on this entire list. Many Honda engines, especially the legendary K-Series 4-cylinders and J-Series V6 engines, use mechanical valve lash adjustment systems rather than fully hydraulic lifters. That means valve clearance changes naturally over time as components wear and heat cycle. Most owners never even know valve adjustments exist. The problem starts slowly. Valve clearances tighten gradually as valves wear into their seats over tens of thousands of miles. When clearance becomes too tight, the valve no longer seals fully during combustion. Compression begins leaking past the valve face. Exhaust valve temperatures skyrocket because the valve cannot transfer heat properly into the cylinder head. This is where the repair bill begins. The engine may develop a slight ticking noise. Idle quality changes subtly. Fuel economy drops slightly, and eventually misfires appear under load. But by the time symptoms become obvious, exhaust valves may already be burned. Burned exhaust valves are extremely common on neglected J35 engines in the Pilot, Odyssey, Ridgeline, and Accord V6, especially once mileage climbs past 120,000 miles without valve service. A valve adjustment costs roughly $350 to $700 depending on engine accessibility. Replacing burned valves and rebuilding cylinder heads can exceed $3,500. And because Honda engines are famous for reliability, owners assume maintenance this specific cannot possibly matter. It matters enormously. Number 9. Ignoring carbon buildup on direct injection Hondas. If your Honda uses direct injection, carbon buildup is not optional, it is inevitable. The 1.5 turbo found in the Civic, CR-V, and Accord, the 2.0 turbo in the Accord Touring, the newer direct-injected Earthdreams engines across the lineup, all of them eventually develop intake valve carbon accumulation. Here's why. In older port-injected engines, fuel sprayed across the intake valves, constantly washing away oil vapor deposits. Direct injection changes that entirely. Now, fuel sprays directly into the combustion chamber. The intake valves never get cleaned. Meanwhile, the PCV system constantly routes oil vapor and combustion gases back through the intake tract. Those vapors bake onto hot intake valves layer by layer over tens of thousands of miles. At first, the buildup is invisible to the driver. Then, airflow efficiency drops. Idle quality deteriorates. Turbo spool characteristics change. Misfires begin appearing under boost. Fuel economy declines gradually enough most owners never notice. On turbocharged Hondas, the issue becomes even severer because higher crankcase pressure increases vapor contamination. Eventually, walnut blasting becomes necessary. That service costs roughly $400 to $900, depending on engine configuration. Ignore the buildup long enough and valves may stop sealing properly. Injector spray patterns become disrupted by turbulence, and catalytic converter stress increases from incomplete combustion. Most owners believe the engine simply feels older. No, the airflow system is literally choking itself internally.
Number 8. Using cheap gasoline in turbocharged Hondas. This mistake looks like smart budgeting right until the engine starts quietly pulling timing every time you accelerate. Honda's turbocharged engines, especially the L15 1.5T and K20 C4 2.0T, are highly efficient because they operate near the edge of combustion optimization. Turbocharging increases cylinder pressure dramatically. That means fuel quality matters far more than most owners realize. Technically, some of these engines can run on regular 87-octane fuel, but can run and runs properly long-term are very different things. The problem starts under boost. Low-octane fuel resists detonation poorly. As cylinder pressure rises, NOx sensors detect abnormal combustion events, and the ECU immediately retards ignition timing to protect the engine. Power drops. Combustion inefficiency worsens. Exhaust gas temperatures rise. That excess heat quietly stresses turbocharger bearings, catalytic converters, and exhaust valves. And because the ECU constantly compensates, most owners never realize anything is wrong. The car still drives, it just operates permanently below its intended efficiency. Over time, chronic knot correction contributes to carbon buildup, increased oil dilution, and catalytic converter degradation. On the 1.5 turbo specifically, fuel dilution already became a major concern in colder climates due to short trip operation. Poor fuel quality compounds the issue significantly. A turbocharger replacement on an Accord 2.0T can exceed $3,000. Catalytic converter replacement on a Civic Sport Touring can push beyond $2,500. The difference between cheap fuel and quality fuel over a fill-up is often less than the price of coffee, but the long-term mechanical consequences are exponentially larger. Number 7. Neglecting the PCV valve. This tiny component has quietly destroyed an unbelievable number of Honda engines. The positive crankcase ventilation system exists to relieve pressure inside the engine crankcase and route combustion blow-by gases back into the intake system. When the PCV valve clogs, pressure builds internally. That pressure has to go somewhere. Oil starts pushing past seals and gaskets. Moisture contamination increases inside the crankcase. Sludge formation accelerates. Oil consumption rises. Carbon buildup worsens dramatically. On Honda engines like the K24 and J35, a restricted PCV system also increases crankcase vacuum irregularities that interfere with proper oil control ring function. Most owners never replace the PCV valve because it is cheap and invisible. There's no dramatic failure event, no warning light, no catastrophic sound, just slow internal contamination. The engine begins consuming oil slightly faster, deposits accumulate inside the intake tract, valve cover gaskets start leaking, rear main seal seepage develops. Eventually, sludge formation begins restricting oil passages. A PCV valve costs roughly $20 to $50. Replacing leaking seals and repairing oil sludge damage can exceed several $1,000s. And the number one mistake on this list becomes even more destructive once crankcase ventilation starts failing. Number 6. Neglecting suspension components until tire wear appears. Honda owners often tolerate worn suspension far longer than owners of luxury vehicles because Hondas usually continue driving reasonably well even when components are heavily worn. That creates a dangerous illusion. On the Accord, Civic, CR-V, and Pilot, suspension bushings, ball joints, tie rods, sway bar lengths, and struts all wear gradually over time. The driver adapts subconsciously to the declining ride quality. Meanwhile, alignment geometry slowly shifts, camber angles drift, toe settings change dynamically during acceleration and braking, tires begin scrubbing across pavement at improper angles, wheel bearings absorb uneven loads constantly. Most owners notice the tire wear first. What they do not realize is the worn suspension already stressed multiple other systems before the tires ever showed symptoms. On heavier Hondas like the Pilot and Passport, worn lower control arm bushings can create instability under braking that increases ABS intervention frequency. Bad struts allow excessive wheel hop, which accelerates CV axle wear. Steering racks absorb impacts they were never designed to handle repeatedly over thousands of miles. Replacing a set of tires on a Pilot costs around $1,000. Rebuilding the front suspension and steering system after years of neglect can exceed $3,500. And worn suspension creates another hidden problem. It increases drivetrain shock loads every time the vehicle hits uneven pavement. That becomes critically important for the mistake coming next.
Number 5. Using anything except genuine Honda transmission fluid. This is where enormous numbers of Honda transmissions begin dying. Honda automatic transmissions are unusually sensitive to fluid chemistry, especially older 5-speed automatics and modern CVTs. Honda does not simply recommend their proprietary ATF and CVT fluid because of branding. The friction modifiers and viscosity characteristics are specifically engineered around Honda clutch materials and hydraulic calibration. Universal transmission fluids claim compatibility with everything. That is the problem. A fluid designed to work well enough across multiple manufacturers rarely behaves exactly how Honda transmission control systems expect. The problem starts with shift quality. Shifts become slightly harsher or slower. Torque converter lockup behavior changes subtly. Hydraulic pressure response becomes inconsistent under heat. Clutch engagement timing drifts slightly from factory calibration. That slight difference creates extra heat every single shift cycle, and Honda transmissions hate heat, especially CVTs in the Civic, HR-V, and Accord. The steel belt and pulley system inside a CVT relies on extremely stable fluid friction characteristics. Incorrect fluid chemistry accelerates pulley wear, belt slippage, and bearing stress rapidly. A CVT fluid service using genuine Honda fluid costs roughly $180 to $300. Replacing a failed Honda CVT routinely exceeds $6,000. And there is still one transmission mistake ahead that has destroyed even more Hondas than incorrect fluid ever did. Number 4. Ignoring VCM problems on Honda V6 engines. If you own a Honda Pilot, Odyssey, Accord V6, or Ridgeline equipped with variable cylinder management, this may be one of the most important sections in this entire video. VCM allows the engine to deactivate cylinders during light cruising conditions to improve fuel economy. On paper, it sounds brilliant. In practice, it created massive long-term wear issues for many owners. The problem starts with uneven engine operation. When cylinders deactivate repeatedly, temperature distribution inside the engine changes constantly. Some cylinders operate hotter, others cool excessively. Oil control ring behavior becomes inconsistent between active and inactive cylinders. Over time, excessive oil consumption develops. Spark plugs foul prematurely. Engine mounts wear rapidly from vibration changes during cylinder activation and deactivation. But the most serious problem is what happens inside the piston rings. Certain cylinders accumulate carbon deposits far faster because combustion temperatures vary unpredictably. Oil control rings begin sticking. Compression efficiency drops. Misfires develop under load. Many Honda owners first notice the issue as vibration during highway cruising. Then comes the flashing check engine light. Replacing active engine mounts on a VCM-equipped Odyssey can exceed $1,800. Oil consumption repairs involving piston ring replacement can surpass $5,000. Some owners install VCM disabling devices specifically to prevent long-term wear patterns from developing. And still, none of these repairs compare to the catastrophic damage caused by the top 3 mistakes on this list. Number 3, believing Honda transmissions have lifetime fluid. This myth has destroyed more Honda transmissions than almost anything else. The phrase lifetime fluid sounds reassuring. It sounds like engineering advancement. What it actually means in practice is many owners never service the transmission at all. Transmission fluid is not permanent. It cannot be permanent. Inside every automatic transmission and CVT, fluid experiences constant thermal cycling, shear stress, clutch contamination, and microscopic metal particle accumulation. Over time, viscosity changes, friction modifiers degrade, cooling efficiency drops. Honda transmissions already operate with relatively tight thermal margins compared to some competitors. Once fluid degradation accelerates, internal temperatures rise rapidly. The damage begins invisibly. Clutch packs glaze, valve body passages accumulate debris, solenoids respond slower under heat, bearings develop microscopic wear patterns, CVT pulley faces begin polishing unevenly. By the time symptoms appear, the wear is already extensive. Delayed engagement when shifting to drive, slight shudder during acceleration, RPM flare between shifts. These are late-stage warnings, not early ones. Honda CVTs should ideally receive fluid service roughly 30,000 to 40,000 miles under real-world driving conditions, especially in hot climates or heavy traffic. A drain and fill service costs a few $100s. A replacement CVT costs as much as an older Civic itself. And the next 2 mistakes destroy engines even faster than neglected transmissions destroy gearboxes.
Number 2. Ignoring the timing belt service on J-Series V6 engines. If you own a Honda Pilot, Odyssey, Accord V6, Ridgeline, Acura MDX, or older Acura TL with a J-Series engine, this is not optional maintenance. This is survival. Honda specifies timing belt replacement roughly every 90,000 to 105,000 miles depending on the application. Most owners delay it because the engine still feels fine. There is no warning light, no major symptom. That is exactly what makes this so dangerous. The J35 and related V6 engines are interference engines. That means the pistons and valves occupy overlapping physical space inside the cylinder at different times. The timing belt keeps them synchronized perfectly. When the belt fails, synchronization disappears instantly. The pistons slam directly into open valves at full engine speed. Valves bend, pistons crack, cylinder heads shatter internally. The engine effectively destroys itself in less than a second. And timing belts rarely provide dramatic warnings before failure. No gradual slipping, no loud squealing. Often, they simply snap. The complete timing belt service, including tensioner, idler pulleys, and water pump, typically costs $1,200 to $2,000 depending on the model. An engine replacement after belt failure can exceed $8,000. Many owners postpone the service because the vehicle still drives perfectly at 110,000 miles. That confidence disappears instantly the moment the belt breaks. Number 1. Stretching oil change intervals and using cheap oil filters. This single mistake has destroyed more Honda engines than almost anything else on this list combined. And what makes it so dangerous is how normal it feels. Honda engines are efficient, tightly engineered, and capable of extremely high mileage. Owners hear stories of Civics reaching 300,000 miles and assume the engine can tolerate neglect indefinitely. It cannot. Modern Honda engines operate with tighter oil passages, higher operating temperatures, variable valve timing systems, turbocharging, direct injection, and extremely precise hydraulic tolerances. Oil quality is absolutely critical. The problem starts when owners stretch oil changes far beyond reasonable intervals or use low-quality oil filters that cannot properly maintain filtration efficiency under heat and pressure. Cheap filters often use weak bypass valves in low-grade filter media. Under cold starts or high RPM operation, unfiltered oil circulates through the engine, carrying microscopic contaminants directly into camshaft journals, VTEC components, turbocharger bearings, and timing chain systems. Then, sludge formation begins. especially on engines subjected to short trips, heavy traffic. This single mistake has destroyed more Honda engines than almost anything else on this list combined. And what makes it so dangerous is how normal it feels. Honda engines are efficient, tightly engineered, and capable of extremely high mileage. Owners hear stories of Civics reaching 300,000 miles and assume the engine can tolerate neglect indefinitely. It cannot. Modern Honda engines operate with tighter oil passages, higher operating temperatures, variable valve timing systems, turbocharging, direct injection, and extremely precise hydraulic tolerances. Oil quality is absolutely critical. The problem starts when owners stretch oil changes far beyond reasonable intervals or use low-quality oil filters that cannot properly maintain filtration efficiency under heat and pressure. Cheap filters often use weak bypass valves in low-grade filter media. Under cold starts or high RPM operation, unfiltered oil circulates through the engine, carrying microscopic contaminants directly into camshaft journals, VTEC components, turbocharger bearings, and timing chain systems. Then, sludge formation begins, especially on engines subjected to short trips, heavy traffic, turbocharger heat, or neglected PCV systems. Moisture contamination mixes with degraded oil. Deposits accumulate inside narrow oil passages. Oil flow to critical components becomes restricted gradually. The damage is already happening long before the engine makes noise. Timing chain tensioners lose hydraulic pressure. Turbo bearings experience lubrication starvation. Cam phasers stick. Variable valve timing systems become contaminated internally. On the 1.5 turbo engines, fuel dilution compounds the issue even further because gasoline contamination breaks down oil viscosity faster under repeated short-trip operation. A synthetic oil change using a high-quality OEM filter costs maybe $80. Replacing a turbocharger on an Accord 1.5T can exceed $3,500. Timing chain repairs on neglected engines routinely surpass $2,500. Full engine replacement on a modern Honda often lands between $6,000 and $10,000, depending on the model. And unlike many failures on this list, oil neglect damages every internal surface in the engine simultaneously. There is no single repair afterward. The entire engine ages prematurely from the inside out. Those are 15 mistakes that can quietly turn one of the most reliable vehicles on the road into a financial disaster. Every single one of them is avoidable, and if even one of these habits sounded familiar, your Honda is already better off because you caught it before the repair bill started. If you want to see which Honda engines are actually the most reliable ever built and which ones you should absolutely avoid buying used, that video is on screen right now. Subscribe so you don't miss it.